Here's a sentence that shouldn't make sense. China claims to have built one of the fastest supercomputers on Earth, a machine capable of 2 quintillion calculations every single second. And it did it without using a single one of the chips the world believes you strictly need to get there. No Nvidia, no AMD graphics hardware, no accelerators, not a single GPU inside the entire system. If you follow technology even casually, you know how wild that sounds. The global AI boom, the race for computing supremacy, the meteoric rise of Nvidia into one of the most valuable companies on the planet. All of it relies on GPUs. Graphics processing units are the beating heart of modern high-performance computing. Building a world-class supercomputer without them is like trying to build the world's fastest race car without an engine. And yet, that's precisely what China says it accomplished. The machine is named Lian Shen. Whether you view it as a genuine architectural breakthrough or clever national theater, the strategy behind it is one of the most revealing stories in modern tech. Because this isn't just about a computer, it's about what happens when you take someone's primary tool away and they decide to win without it anyway. By the end of this video, you'll understand what Lian Shen actually is, why going GPU-free was the entire strategy, why industry experts remain skeptical, and what this signals for the future of global tech dominance. Let's dive in. Let's start with scale, because these numbers are staggering. A supercomputer isn't one giant PC. It's thousands of individual servers networked together so tightly they operate as a single colossal brain. We measure their speed in flops, floating point operations per second. Basically, how many math problems the system can solve in a single clock tick. The top tier today operates at the exascale level. 1 exaflop is a billion calculations per second. To visualize that, if every human on Earth completed 1 calculation per second by hand, it would take roughly 4 years to match what an exascale machine does in 1 second. Lian Shen is targeting 2 exaflops. These machines aren't built for web browsing or gaming. They power humanity's most complex challenges, simulating nuclear physics, predicting global climate shifts, designing pharmaceuticals atom by atom, and training massive AI models. Supercomputing leadership isn't a vanity metric. It's a direct marker of national capability in science, defense, and AI. For the last few years, the reigning champion has been an American machine called El Capitan, housed at Lawrence Livermore National Laboratory. It boasts a verified, measured performance of about 1.8 exaflops. Keep that word verified in mind. It's critical. El Capitan achieves its speed using roughly 44,500 specialized chips that blend CPU and GPU technology. Relying heavily on GPUs isn't unusual. It's the industry standard. GPUs excel at running thousands of simple, identical math operations simultaneously in parallel. That parallel processing is exactly what AI and complex scientific simulations demand. So when China announced a machine aiming to beat El Capitan, everyone assumed it would deploy a massive array of new GPUs. Instead, China announced 0 GPUs, just central processors, CPUs, the same general-purpose architecture that runs standard servers, only scaled up across 47,000 chips. Why deliberately take the harder route? Think of it this way. A GPU is like an army of 10,000 elementary students who can only do basic addition, but all at the exact same moment. A CPU is like a small team of university professors who can handle complex, varied logic, but there are far fewer of them. For massive parallel calculations, the army of students is far more efficient. Choosing CPUs only sounds like choosing a massive handicap. The answer comes down to one word: restrictions. China has been cut off from buying top-tier GPUs due to Western export controls. The exact Nvidia silicon powering machines like El Capitan is off-limits. China faced 2 choices: try to bypass sanctions to buy forbidden chips and remain permanently behind, or ask a radical question: can we reach the top using hardware we manufacture entirely on our own? Lian Shen is their answer. Chief designer Liu Yutong stated the goal clearly. The system must be fully independently controllable. Every layer, processors, storage, networking, software, is domestic. The pilot build runs on 100 Huawei Kunpeng servers, designed to scale to 47,000 CPUs across 92 cabinets, linked by a custom 1 million port interconnect moving 10 terabytes of data per second. The GPU-free design isn't a flaw China is trying to hide. It's the whole point. The constraint became the roadmap. Of course, you can't just wire 47,000 basic CPUs together and magically claim a world record. China had to engineer several key workarounds. On-chip high-bandwidth memory. They stacked ultra-fast memory directly onto the processors, drastically reducing the time wasted moving data back and forth. 3D floating orthogonal architecture. A specialized topology designed to keep tens of thousands of chips communicating efficiently without choking internal bandwidth. Full direct liquid cooling. Liquid cooling channels heat away far more effectively than air, allowing 47,000 dense processors to sustain peak performance. It's a thoughtful, coherent architecture, not just a random pile of server chips. But did it actually work? Here's where we need to separate marketing from reality. Target versus benchmark. That 2 exaflop figure is a theoretical target, not a proven score. El Capitan's 1.8 exaflops was verified using the official LinPack benchmark. Lian Shen hasn't submitted a verified benchmark because the full machine isn't fully completed yet. Peak potential. While Lian Shen targets 2 exaflops, El Capitan's theoretical peak is actually higher, around 2.79 exaflops. Manufacturing limits. China's domestic chip production remains constrained. Whether they can reliably manufacture, deploy, and synchronize 47,000 of these processors remains an open question. The real takeaway isn't that China definitively built the fastest machine today. That headline claim is premature. The real story is that China demonstrated a credible, fully domestic, GPU-free blueprint toward exascale computing. Whether Lian Shen hits its target next year or 5 years from now matters far less than the strategic shift it represents. A computing stack built entirely from domestic components, chips, interconnects, software cannot be disrupted by foreign export policies. It is harder to build initially, but once operational, it is completely immune to trade sanctions. GPU export restrictions were designed to bottleneck China's computational power. Instead, they forced China to pioneer an independent path. The leash didn't stop the growth. It just forced the system to evolve in a direction beyond Western leverage. So, what's your take? Were the GPU restrictions a solid strategy to buy time? Or did they simply accelerate China's push toward total technological independence? Let me know in the comments below. If you want to keep tracking these developments before they hit mainstream headlines, hit subscribe and turn on notifications. Thanks for watching, and I'll see you in the next one.